So let's take a look at 5.5. So in 5.5, we're dealing with negative exponents. So let's start out with this one. So one thing we have to recognize is, what is this exponent attached to? If we don't have a parenthesis, the -1 is only attached to the x. So if you watch the videos that cover this section as far as a lecture, then when we have a negative exponent, that's like a red flag telling us that that's in the wrong location. So if we have an x with a negative exponent in the numerator, and you might say, what do you mean in the numerator? There's not a fraction. If we were to put this whole thing over 1, it is a fraction. So to make the exponent positive, we simply move it across the fraction bar. So now we can have x to the +1 on bottom. 6 did not have that negative exponent, so it stays where it is. So we only move something if it has a negative exponent. So we could write it this way, or we could write it 6 over x. That exponent of 1 is not necessary. All right. So then if we take a look at the next one, this is a little larger. We can do this a couple of ways. If you would like to get rid of the negative exponents first, we can do that. So we have a negative exponent here that tells us that this factor is in the wrong place, so it needs to go to the bottom. This has a negative exponent also. It's in the wrong place, so it needs to go to the top. So we end up with a to the +5 on bottom, a to the +8 on top. Now that simplifies. Remember, one of our rules said if we divide and our bases are the same, we subtract the exponents. And we take the exponent on top minus the exponent on bottom. So that'll give us a to the 3rd. Now we could have done that without getting rid of the negative exponents first. We could have used our quotient rule here. We're dividing. We have the same bases. So we could take the exponent on top minus the exponent on bottom. Notice minus a negative makes a positive. So we have a to the -5 plus 8, which is still a to the 3rd. So either way you want to do that is fine. I did it this way just to illustrate, again, that negative exponents mean that that factor is on the wrong side of the fraction bar. Okay, so we could do the same thing here. We could begin by going ahead and using product rules, quotient rules, or we could begin by getting rid of the negative exponents. So the r on top doesn't have a negative exponent, so it stays on top. This r has a negative exponent, so it needs to go to the top. So instead of dividing by r to the -8, we're going to multiply by r to the +8. And same thing with this one. That one needs to go to the top. And we'll have r to the 7th. So instead of dividing this r by the 2 on bottom, we're going to multiply by those same r's, but with positive exponents. Nothing is left on bottom except an understood 1. Now we just have a product, and our product rule says that if we're multiplying and our bases are the same, we add our exponents. This first r has an understood 1 as an exponent, so when we multiply those, we add 1 plus 8 plus 7. That tells us how many r's are multiplied together. So we end up with r to the 16th. 16 different r's are multiplied together. 1 here, then 8 more, and I'm not going to write all of those. So 1, 8 more, and then 7 more. So if we have 1 and then 8 more, that would be 9 that are multiplied together. And then if we have 7 more, 9 and 7 more, that's 16 r's that are multiplied together, which is what r to the 16th means. So that's, of course, we don't have to do this last step down here. That's just a reminder for those of you that might still be struggling a little bit with Why are we adding our exponents? We're looking for how many total r's are being multiplied together. Okay, this one we have to be a little careful with because we have addition. So we have two different terms. We have a term here and a term here, and I'm just putting a 1 underneath them because we have negative exponents. And remember, with negative exponents, that tells us we have that factor in the wrong location. So for the first one, that 2 to the negative 2, that needs to go to the denominator. But since we have two different terms, we have two different fractions. So that 2 to the second goes to the denominator of the first fraction. Nothing is left on top except a 1. Same thing here. On the other side of the plus sign, we have a 2 to the first that goes to the bottom, and once we move it, the exponent becomes positive. And we're left with a 1 on top. So for the first fraction, we have 1/4. For the second fraction, we have 1/2. But then we run into a dilemma. We can't add those currently because we don't have a common denominator. So to get a common denominator, we need to know what is, or to add these, we need a common denominator, and that common denominator would be 4. So we're going to write each fraction with a 4 on bottom. The first fraction already has a 4 on bottom, so we keep it. To make the second fraction have a 4 on bottom, we would need to multiply the bottom by 2, but we also have to multiply the top by 2. Now that both fractions have the same denominator, we keep the denominator, add the numerators, and we would get that. That's a little bit of review on how we add or subtract fractions. So we have a multiplication problem. So let's move this over. Make it a little bigger. So everything is being multiplied together. So if we want to, we can rewrite this and reorganize it. We can put our coefficients beside each other. We can put our x's beside each other. And we can put our y's beside each other. So if you like to get rid of your negative exponents first, that's perfectly fine. But let's go ahead and use our power rules, because once we combine our exponents, they may no longer be negative, so we might not have to move them. That's not completely necessary. There are a couple of different orders we can go in here, and part of that is because in order of operation, multiplying and dividing are of equal importance. They just go left to right. So if we move this to the denominator, we would be dividing by x squared. If we left it on top, we'd be multiplying by x to the negative 2. So it's really not necessary that we take care of that negative exponent to begin with, but we can. I'm just going to go left to right, and I'm going to multiply those together. And then to combine those, we have the same base, so we can add the exponents. The first exponent plus the second exponent. And then I'm going to put those together. Those are multiplied, so I'm going to take the first exponent plus the second exponent. So we have a negative 12 out front. We have x to the 5 minus 2, which is 3. We have y to the negative 4 plus 2. Opposite signs we subtract. Take the sign of the bigger number, or put it in your calculator. Once we do that, one of our exponents is positive, one is negative. So the one with the positive exponent stays where it is. So the x cubed stays on top. The y to the negative 2, that exponent is negative, so we take it to the denominator. We don't move the negative 12 because the negative is not in the exponent. The negative is just a part of the coefficient. But if we have a negative exponent, that factor goes to the denominator. Okay, so if we want to simplify this, order of operation tells us to simplify on the inside first. We can do that. So on the inside, we're dividing, and both of those have the same base. So to combine those on the inside, we subtract their exponents. We take the exponent of the one on top minus the exponent on bottom. And then for our y's, we're dividing, and those have the same base, so we subtract those exponents. 5 minus 8. So for the x's, -1 minus 2 is -3. For the y's, 5 minus 8 is -3. And then that's being raised to the third power. So we could either go ahead and move the negatives to the bottom and then cube it, or we could distribute our exponent first. I'm going to go ahead and distribute the exponent. What do I mean? Remember, if we have a product, each portion gets that exponent. So x to the -3 gets cubed. Y to the -3, that also gets cubed. And then we have a rule that says if we have something with an exponent and then that's raised to a power, we multiply those exponents. So -3 times 3 is -9. Again, -3 times 3 is -9. So that's good, but we don't need to leave negative exponents. So if we consider that a fraction, the pieces with a negative exponent get moved to the bottom. So the x to the -9 goes to the bottom and becomes x to the +9, and so does the y. And both factors on top leave, so we're only left with a 1 on top. All right, so let's do another one of these. These problems can look intimidating, and one of the biggest things is not to try to do too much at one time, not to get intimidated. So remember, order of operation. We have to do what's in parentheses first. So we have parentheses here, and on the inside of that parentheses, we can't combine any of those. We could get rid of that negative exponent by moving it, but we would have to be careful where we do that. So I like to make parentheses go away before we start moving negative exponents from top and bottom. And hopefully in a minute we'll see why that is. It's going to get confusing because before we can move anything in that parenthesis to the denominator, it has to get raised to the -5th power. But as far as on the inside of the parenthesis, there's nothing we can really do. We can do something to the parenthesis using an exponent, but on the inside of that parenthesis, nothing can really be done. And the same is true here. So on the inside of the parentheses, nothing really to do. So the next thing is exponents. So let's apply this exponent to that parenthesis. We have 3 things multiplied together on top inside that parenthesis. So -2 is going to be raised to the -5th power. X is going to be raised to the -5th power. And y to the -2 is going to be raised to the -5th power. And it is important that we put parentheses around those before we write the exponents. We're going to do the same thing on bottom. We have a product in the parentheses, so the x gets raised to the -3, and the y to the -2 also gets raised to the -3. What we're not able to do is we're not able to say, hey, here's a y to the -2 and here's 1, so we can cancel those out. Well, we have to do our exponents before we do that. Why is that? Because when we cancel from top to bottom, that's essentially dividing. Dividing comes after we apply exponents. So we have to make those parentheses go away by applying those exponents, and then we can see about dividing. So let's see what we can do now. I'm going to leave that -2 to the -5 alone for now, and let's take care of the other pieces. So we have x to the first, and that's raised to the -5, -5. So that makes x to the -5. When we raise this to the -5, we multiply those exponents. So -2 times -5 is 10. On bottom, we have an x to the -3. And then when we raise this to the -3, we multiply those exponents. So we get y to the +6. Okay, so let's take care of several things now. So in our fraction, we have a number raised to a negative power. So to make that negative exponent go away, we need to move -2 to the denominator and make the exponent positive. Now, if you prefer, you can move those and then subtract them. But since we're dividing and our bases are the same, let's just go ahead and subtract those exponents. If we have x to the -5 on top, x to the -3 on bottom, dividing like bases, we simply take the exponent on top minus the exponent on bottom. So minus a negative, we'll make that a plus. So that's really -5 plus 3, so that makes x to the -2. When we deal with the y's, we have y to the 10th on top, y to the 6th on bottom. So if we subtract those exponents, 10 minus 6, we get y to the 4th. Okay, we only have one piece left that has a negative exponent. That's this one, so we can move the x down and make that x squared. Y stays on top because its exponent is positive, and then we just need to raise -2 to the 5th. We don't move it anywhere because the exponent is positive. It doesn't matter that the base is negative. It doesn't get moved because of the base. It only gets moved if the exponent is negative. So we have -2 times -2 times -2 times -2 times -2. Well, an odd amount of negatives is negative because 2 negatives make a positive, 2 negatives make a positive. All of those are positive times a negative. Positive times negative is negative. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 32. And there's nothing left that we can do to simplify that. Our exponents are positive, none of our bases are the same, so nothing to reduce, nothing to move. Even though 32 is negative, that's a base, that's not an exponent, so it doesn't get moved across the fraction bar. So the remainder of this section deals with scientific notation. So if you watch the videos, if you remember from things in the past, scientific notation deals with writing things as a number times 10 to some exponent. And the number that 10 to a power is multiplied by can only have a single digit in front of the decimal. So we can't have 2 numbers in front of the decimal, or 3, or none. We have to have exactly 1 digit in front of the decimal. So if we convert this problem into scientific notation, or this number, our decimal starts here, and it needs to move between the 4 and the 3. So we're going to have a 4.3, and then everything else is zeros. 43,000, that's a fairly large number. So for large numbers, our exponent here is positive. Sometimes people memorize, if you move the decimal this way, you end up with a positive exponent. If you move it that way, you have a negative exponent. But the way I deal with it is if it's a large quantity, not a larger, but a large quantity, our exponent is positive. If it's a tiny quantity, we have a negative exponent. We can illustrate that by just looking at some numbers. If we take something like 10, oops, it's not, change here. If we do something like 10 and raise it to the fourth power, that gives us a pretty big number. But if we take 10 and we raise it to the negative 4 power, that gives us a tiny number. So if a negative exponent in scientific notation means a tiny amount, a positive exponent means a large amount. So the number of places we move is based on how, or our exponent is based on how many places our decimal gets shifted to go to scientific notation. So if we started here, we moved 1, 2, 3, 4 places. So our exponent is 4. That's a largish amount, so our exponent is positive. So 4.3 times 10 to the fourth is that value in scientific notation. That just keeps us from having to write lots and lots of zeros when we have really, really big numbers or really, really small numbers. If we look at this one, this is a really, really small number. It's a really tiny decimal. If we think about it as a distance, let's say in inches, 0.0000173 inches, that's a very, very tiny amount. Maybe the thickness of a hair or something like that. Our decimal needs to end up here. So the number in front of the times 10 needs to be 1.73. Notice exactly one digit in front of the decimal that's not a 0. And then it's going to be 10 to a negative power, very tiny quantity. And our exponent is going to be 1, 2, 3, 4, 5, 6, because we moved our decimal 6 places. So that's putting it in scientific notation. If we have a number and we want to take it out of scientific notation, we use the same logic. We have a negative exponent, so this is going to be a tiny amount. So if we have 8.198 and we need to move the decimal 9 places and end up with a tiny number, we're not going to move it to the right, because if we move it to the right, that's going to be really, really big. That's not going to be a tiny decimal. So in order to make this a tiny decimal, our decimal will need to go to the left 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So in standard form, this number is 0.000000008198. Notice that's a really tiny number. Our decimal is shifted 9 units from where it started. So that's scientific, that's standard notation. Same type of thing here. We're just going the other direction. Since our exponent is positive, this is a large quantity, so we need to take this number that starts with a decimal here and move the decimal in a direction so that we get a large quantity and move it 8 places. So we would need to go to the right. So if we start here, we go 1, 2, 3, 4, 5, 6, 7, 8 places. So we would end up with 1, 3, 3, 4, 0, 0, 0, 0, 0. So that's 133,400,000. Now we have one last problem that we're going to work, and this deals with multiplying numbers in scientific notation together. Notice all of this is multiplied. We have a product here, this is a product, this is a product, and if everything is a product, we can rearrange it. So let's call this 8 times 9 times 10 to the negative 9 times 10 to the negative 9. So 8 times 9 is 72, and to multiply those together, those have the same base, so we add the exponents. Negative 9 plus negative 9. Our signs are the same, so we add the digits, keep the sign of the bigger, so that's 10 to the negative 18. Well, that was simple enough, but that's not yet in scientific notation. Notice the number out front has 2 digits to the left of the decimal, not just 1, because our understood decimal is there. So there are a variety of ways of going about doing this. For some people, the simplest way is just to convert 72 into scientific notation and proceed from there. So if you think about your decimal starting here, it needs to end up here to be in scientific notation. So we need 7.2 times 10 to some power. If we start here and we move to there, we've only moved one place. And the number 72, that's not one of those tiny decimals. So we don't need a negative exponent, we need a positive one. You could type that in your calculator to check to make sure that, yes, 7.2 times 10, or times 10 to the first, is 72. So if we say take 7.2 times 10 to the first and multiply that times 10 to the negative 18, those have the same base, so we just simply add those exponents. 1 plus negative 18, different signs, we subtract the numbers, take the sign of the bigger. So now that's in scientific notation.